We hear so much about what AI can do, but today we're asking a way more fundamental question. How is it actually being built? We're going to peel back the layers here, all the way from the custom silicon being forged in foundries to the legal code being written in state houses. We're going to look at the blueprint of synthetic reason. So let's dive in.
Smarter AI is a great headline, right? But what does that even mean? The real story here isn't just some abstract intelligence floating in the cloud. Nope. It's about the very real, very concrete choices being made right now. We're talking about its physical brain, its digital mind, and even the laws we're starting to wrap around it. This is the AI stack, and we're going to explore it from the ground up.
Okay, first up, the silicon foundation. We have to start at the bedrock of it all, right? The hardware. And what's happening right now isn't just a race for faster chips. It's a high-stakes debate over the right way to build a physical brain for a brand new kind of intelligence.
So you've basically got two competing philosophies here. On one hand, you have the bespoke, custom approach. Think OpenAI designing a tailor-made brain for its very specific vision of AI. And on the other hand, you have the industrial powerhouse, NVIDIA, the undisputed king of AI hardware, building these enormous AI factories designed to power 1,000 different visions at once. These are two very different bets on how the future's going to play out.
So let's take a look at OpenAI's big move. They're developing their own custom chip, and they're calling it Sovereign One. And that name, it says it all. The goal here is independence, sovereignty. By designing their own silicon, they can fine-tune it for the exact kind of AI they want to build, and, maybe just as importantly, they can escape the massive, crippling costs of relying on somebody else. It's a declaration of hardware independence.
So what is that specific kind of thinking they're building this for? Well, it's what the experts are calling reasoning-heavy workloads. Now, this isn't about just, identifying a cat in a photo. This is about complex, multi-step problem solving. Think logic puzzles, complex causal chains. They are building a chip that is physically designed from the ground up to reason.
Meanwhile, you've got NVIDIA, and they're just doubling down on what they do best: massive, unbelievable scale. They're building these AI factories, using incredible automation tech like digital twins, which are basically virtual replicas of the entire factory to optimize every single step of production. Their goal isn't to build one custom brain. It's to mass-produce the powerful engines for 1,000 different AIs across the entire planet.
Okay, so this all leads to a really big question, right? We are building the most powerful computational engines in the history of the world. But what new kinds of thought can they actually power? To answer that, we have to move up the stack to the next layer.
And that brings us to the reasoning layer. So if the silicon is the brain, then this is the mind. It's the software, the architecture that's running on that new hardware. And honestly, this is where things get really, really interesting. Because that mind, it's starting to wake up in some pretty surprising ways.
Just listen to this. Google DeepMind just announced a major breakthrough they're calling verifiable reasoning. What does that mean? Well, for the first time, a large language model can actually check its own work. Just think about that for a second. It can literally pause what it's doing, verify its own logic against formal proofs, and correct itself if it makes a mistake.
Here's kind of how it works. The AI, Gemini, it comes up with a step to solve a problem. And this is the key, before it moves on, it checks that step against formal, provable logic. If it finds a flaw in its own reasoning, it stops. It actually corrects itself and then tries a different path. It's like an AI with a sense of intellectual humility. It's wild.
So why does this matter so much? Because it's a direct assault on one of the biggest plagues of modern AI, hallucinations. When it just makes stuff up. For super high-stakes fields like engineering or mathematics, where one tiny error can be absolutely catastrophic, an AI that can't lie because it is constantly checking its own facts, well, that's nothing short of a revolution. But of course, progress always creates new problems, doesn't it? As these increasingly logical AIs start writing more and more of our software, we slam right into a huge new management challenge. How in the world do you maintain a code base with millions and millions of lines of code written not by a human, but by a machine? Yeah, the problem is something experts call the ripple effect. In a massive system, changing just one single line of code can have totally unpredictable, cascading consequences millions of lines away. And when an AI is making those changes at superhuman speed, that risk just multiplies exponentially.
So, Anthropic's answer to this is a really cool tool for human oversight. Their new Claude Code Enterprise can generate a real-time visual map of an entire code base. This lets a human developer actually see the potential ripple effect of a change before it's ever implemented. It's like a weather map for code, letting us safely navigate this incredibly complex new world that AI is building for us.
So we've got the hardware foundation and the software mind. But that brings us to the final and maybe the most complex part of our stack, the societal interface. Now that this intelligence exists, how do we build the rules for it to operate safely in our world?
All sorts of new challenges are popping up that, honestly, no one really anticipated. A security firm called Wiz has identified this phenomenon they're calling agentic collusion. This is where autonomous AI agents, all working independently for different people, start to unintentionally coordinate their behavior without any direct human instruction.
And here's a real-world example. Automated shopping agents. Think about it. If you have thousands of these agents and they're all told to get the best possible price on a product, they might all learn that the best way to do that is to coordinate their buying patterns in a way that, well, looks an awful lot like illegal price fixing. And it's all happening without any direct human oversight.
So what's the fix? The proposed solution isn't to try and make the agents dumber. It's to make them way more transparent. The idea is, if we can't always predict their behavior, then we absolutely must have the ability to inspect their motives and understand their logic.
And this isn't just some theory, okay? It's actually becoming law. California's Agent Transparency Act is on the verge of passing. It's one of the first major pieces of legislation in the world designed specifically to protect consumers in an age full of autonomous AI agents acting on our behalf.
So what does this bill actually require? Well, it boils down to two really key things. First, an agent has to tell you what model is powering it. Like, is it GPT-5 or Claude 4 giving you that advice? Second, it has to disclose its financial affiliations. So if your shopping agent recommends a certain product, you have a right to know if it's getting a secret commission for doing so. This is all about uncovering and preventing hidden bias.
What all this means is that we're seeing a massive shift in the world of AI. For years, the race was just to build more powerful technology. That's it. But now, an equally important race is on. The race to build the rules, the laws, and the ethical guardrails to manage it all.
Which leaves us with one last thought to chew on. We've seen how AI is getting its own custom-built silicon foundation, a new kind of mind that's capable of self-correcting reason, and it's starting to find its own place in our society. As all of these pieces fall into place, the ultimate question isn't just what we will build, but what this new form of intelligence will ultimately decide to become.